Hi, welcome back to the YouTube channel, An American Professor. Today we're going to be picking back up with the reinforcement learning playlist, but instead of continuing straight away with the tic-tac-toe example, we're going to start off today with, we're going to take a step back and actually go into the fundamentals of reinforcement learning. And my good friend, my best friend Zane, is going to be a guest narrator for today. And he's going to start off by narrating this article, the one I'm sharing right now, A Gentle Introduction to Reinforcement Learning, RL. So take it away, Zane.
RL is a subfield of artificial intelligence, AI, that allows an agent to learn how to achieve a desired outcome or maximize rewards over time through trial and error learning. In this post, I give an introduction to the basics of RL, including some common terminology and example problems. I will also discuss some of the advantages and drawbacks of RL compared to other popular machine learning algorithms. Stay tuned for future posts as well, in which I will go into more detail on specific RL techniques. What is RL and why should we care about it? RL is a subfield of artificial intelligence that deals with how agents should select controls in an environment so as to maximize some notion of cumulative reward. RL is considered by many to be the third generation of machine learning algorithms after supervised learning and unsupervised learning. The notation used in RL is similar to that used in SL, supervised learning, but with two important differences. First, in RL, there is no training data, labeled data. Instead, the agent must learn from experience by trial and error, hence the reinforcement part of the name. Second, most RL problems are formalized as Markov decision processes, MDPs, which are a specific type of mathematical optimization problem. In an MDP, an agent must choose controls in such a way as to minimize a cost function known as the value function, or cost to go. The equations used to solve MDPs, Markov decision processes, are more difficult to solve than a set of linear equations. In particular, the so-called Bellman equations for RL are nonlinear and therefore require much more cleverness to solve. What are some challenges involved in using RL techniques effectively? RL is a modeling technique. It's used to understand and optimize how an agent should behave in a given environment. The key components of reinforcement learning are a state space. A state space are all possible states that the agent can be in. A control space. This is the set of all possible controls that an agent can take. A reward function. This specifies the rewards associated with various state control pairs. And finally, a transition function. This defines the probabilities of transitioning from one state to another given a control. RL is a modeling technique that can be used to understand and optimize complex systems. The key components of RL are modeling, value estimation, and policy optimization. RL can be used to optimize a system by modeling the system's environment and reward structure, estimating the values of states and controls, and then optimizing the policy to maximize the expected reward. The modeling component of RL involves understanding the system's environment and modeling the system's dynamics. The value estimation component of RL involves estimating the values of states and controls in order to identify the optimal policy. The policy optimization component of RL involves finding this policy that maximizes the expected reward. RL can be used to optimize a wide variety of systems, including but not limited to control systems, robotics, resource allocation systems, and game-playing agents. RL algorithms work by modeling the interaction between an agent and its environment.
For the game-playing agents, I just would like to add that you'll see that we'll be able to optimize the game playing in the game of tic-tac-toe. So that's a good segue. All right, back to Zane's wonderful narration.
The most common formalism is the Markov decision process, but there are other formulations as well, depending on the kind and quality of information an agent has for making its decisions. MDPs are suitable when the state is completely observable by the agent, and the MDP model accounts for noise or randomness in the environment. Within an MDP, there are RL methods that allow an agent to identify optimal policies over time from trial and error experience. That is, the agent learns a set of behavior rules that enable it to maximize its expected cumulative reward. In other words, RL algorithms enable agents to learn how to behave in order to achieve their objectives. RL technology is a type of AI that is designed to learn from experience and take controls in order to maximize a reward function or minimize a cost function. This technology has a wide range of potential applications, including games, finance, and robotics. Games provide an ideal environment for RL technology to learn and improve its performance, as there are a fixed set of rules and a clear goal to win the game. Financial applications of RL include automated trading, where the goal is to maximize profits while minimizing risks. In robotics, RL can be used to teach robots how to perform tasks such as navigation, object manipulation, or achieving a desired pose. With its ability to learn from experience and take controls to achieve a goal, RL technology has the potential to revolutionize a wide range of industries. RL is a powerful tool and subfield of AI that can be used to train AI systems to make effective decisions in uncertain environments. RL is a powerful tool for teaching AI agents how to complete tasks by providing positive or negative feedback. However, there are several challenges involved in using RL techniques effectively. It is important to understand the key components of RL and how they work together before attempting to use these techniques. There are many potential applications for RL technology, and businesses should start exploring this area to see if it could be beneficial for them. One option for getting started with RL is to take an online course. There are plenty of resources available online. Coursera has some useful and interesting RL courses, such as the specialization on reinforcement learning. The book Reinforcement Learning, an Introduction by Andrew Bartow, is another excellent resource, and it provides a gentle introduction to the topic. There are other more hands-on ways to get started with RL. One option is to use an existing RL library, such as OpenAI Gym. Future articles I will write cover some of these OpenAI Gym environments and provide discussions of powerful RL algorithms for solving some of the Gym toy problems. And finally, there are numerous blog posts such as those on DeepMind and academic papers that provide intuition and technical details on various aspects of reinforcement learning. With all of these resources, there's no excuse not to get started with RL today.
That was wonderful, Zane. Thank you for narrating. And we'll continue soon after this video, following up with our Fundamentals of RL series. And then before you know it, we'll get back to working on our tic-tac-toe reinforcement learning agent. That's it for this video. Don't forget to hit that like and subscribe button to continue learning about reinforcement learning on this channel.